In this class, we will be seeing regarding portfolio selection. Before talking about portfolio selection, we have to see a theory known as portfolio theory. Portfolio theory is a theory on how risk-averse investors can construct portfolios to optimize or maximize expected return based on a given level of market risk. According to the theory, an investor can construct a portfolio with different financial assets that will maximize return for a given level of risk. It also states that with a desired level of expected return, an investor can construct a portfolio with the lowest possible risk. So in portfolio theory, they are talking about how we can create a portfolio by getting the minimum level of risk and with maximum level of return. So we saw in portfolio analysis that we are analyzing the risk and return of several portfolios created. So portfolio theory is dealing with how these portfolios can be constructed with the minimum risk and the maximum return. A major insight provided by the theory is that investor securities' risk and return characteristics should not be viewed alone but should be evaluated by how the securities affect the overall portfolio's risk and return. We saw that you should not see the security risk and return individually. There is a concept known as interactive risk, where the risk of individual securities interact with the risk of other securities in the portfolio. So, if investors are presented with two portfolios of equal value that offers the same expected return, portfolio theory explains how the investor will prefer and should select the less risky one. On the counter side, if the investors are presented with two portfolios with equal risk, portfolio theory explains how the investor will prefer and select the one with the highest expected return. So this we'll be seeing in detail, that is how we'll be that is you have different portfolios with different expected returns and risk, and from that how we'll be selecting the best portfolio from it. This is an investment theory whose purpose is to maximize a portfolio's expected return by altering and selecting the proportions of the various assets in the portfolio. So we had mentioned that had studied that we can not control the risk and return of our portfolio, but we can alter the proportion of funds invested in the portfolio. So thereby we can alter the proportions and construct a portfolio with the greatest return and lowest risk. In brief, portfolio theory explains how investors can reduce the overall risk by holding a diversified portfolio of assets. Okay. So next is the assumptions of portfolio theory. Asset returns are normally distributed random variables. Investors attempt to maximize expected market returns. Investors are rational and avoid risk when possible. All investors have access to the same sources of information for investment decisions. Investors share similar views on expected returns. Tax and brokerage commissions are not considered. Investors are not large enough to influence the price, and investors have unlimited access to borrow and lend money at risk-free rates. So these are the assumptions, and in this module we are going to see two famous theories discussed for the construction of the portfolios and selection of portfolios. They are known as the Markowitz model and the Sharpe single index model. Before going to Markowitz model, we need to learn regarding two concepts. First one is known as portfolio opportunity set. So we know a combination of securities is called a portfolio, and investor can create a number of portfolios by combining the different securities in different proportions, and we can create a number of portfolios by combining all the assets. So all possible combinations of such assets constitute a feasible set of portfolios, and a group of all feasible portfolios constructed by using the selected securities is called as portfolio opportunity set. So portfolio opportunity set means the number of portfolios we can create with the given securities. That is, in the security analysis phase, we had identified different number of securities, and then in the portfolio analysis phase, we had combined these portfolios in different proportions and we had calculated the risk and return. So suppose we have created 10 portfolios with our given selected securities, then these 10 portfolios is known as portfolio opportunity set. Each portfolio opportunity set or feasible set is a set of all possible portfolios that can be created by using a number of securities. It involves all possible combination of different securities an investor can invest in. A feasible set represents all portfolios that could be formed by a group of n securities. Because portfolios can consist of any number of assets with differing proportions of each asset, there will be a wide range of risk-return ratios. So this, as we told itself, portfolio opportunity set is the number of portfolios or n portfolios which we create by mixing the securities in different proportions. Each portfolio in the opportunity set is characterized by an expected return and a measure of risk, that is standard deviation. So we actually calculated the individual risk and return of a portfolio, which is different from the security risk and return. Not every feasible portfolio is equally desirable to the investor. A portfolio with lower risk and higher or same expected return than that of another portfolio in the opportunity set will be desirable. Therefore, in the opportunity set, some portfolios will obviously be dominated by others. All dominating portfolios are known as efficient portfolios and others are inefficient portfolios. So, this concept we are going to be seeing in detail in the Markowitz model. So, in simple words, we are saying that suppose there are two portfolios and portfolio A's risk is 10 and return is 20, and portfolios B's risk is 20 and the return is 20. So, at a level of 10 risk, we are able to get 20 return. So, obviously the portfolio B, which has 20 risk and only 20 return, will be the inefficient one. That is, the portfolio A offering the less risk and higher return is the dominating one and it will be selected as the efficient portfolio. This concept we will be going to see in detail later. So, a portfolio is said to be efficient if it is expected to yield the highest return possible for the lowest risk or at a given level of risk. That is, I said in that example. A set of efficient portfolios can be generated by using the process of combining various securities whose combined risk is lowest for a given level of return than another feasible portfolios. The output from portfolio analysis can be used to identify the set of efficient portfolios. So, if we had generated 10 portfolios and 10 portfolios have their own portfolio risk and return, we will be selecting the efficient portfolios based on this principle of dominance. Next is the concept known as optimal portfolio. Optimal portfolio is a portfolio that offers the highest expected return for a defined level of risk or the lowest risk for a given level of expected return. That is, we told that by using the principle of dominance, we select the efficient portfolios from it. That is, the portfolios which give the lowest amount of risk at a given level of return. Also the opposite, the highest return at a given level of risk. So, from these efficient portfolios, we are going to be selecting the optimal portfolio. An optimal portfolio is one of the efficient portfolios that provide the most satisfaction or the greatest return for an investor based on his tolerance for risk. An optimal portfolio is the most preferred by an investor because its risk-reward characteristics approximate the investor's utility function. An optimal portfolio maximizes an investor's preference with respect to return and risk. The process of finding the optimal portfolio among the efficient portfolio set is called as portfolio selection. So, we make a number of portfolios, we calculate its risk and return. Then by using the principle of dominance, we find out the efficient portfolios and the inefficient portfolios, and then from the efficient portfolios we find the optimal portfolio. This is the concept we are going to be dealing in portfolio selection. This concept of efficient portfolios can be explained better with a diagram. So in this diagram, that is, we had actually 10 portfolios. Suppose we had 10 portfolios and we are drawing this 10 portfolios in a diagram. So that diagram, the x-axis will be indicating the standard deviation or the risk, and the y-axis will be indicating the return. So this diagram, or the space where this risks and return are plotted, is called as the risk return space. So the first portfolio A has a return of sigma A and a return of RA. That is, in the we had portfolio 1 with an expected return of 4.4 and a standard deviation of 3.2. So suppose we are plotting the standard deviation expected return as 4.4 and the standard deviation, that is 4.4 return and the standard deviation of 3.2, we will get a point known as this dot. That is, we are getting a dot, that is this one. So this dot in the risk return space is called the A portfolio. And again, the next portfolio is expected return 5.01, 4.05. Again, we will be plotting that in the risk return space and we will be getting the portfolio 2. So like that, in this example, they have given 1, 2, 3, 4, 5, 6 portfolios, and they have plotted the 6 portfolios in this risk return space. So what is the explanation? The graph shows the feasible set as well as the efficient set. So portfolio opportunity set means all the portfolios that is constructed from the security. So portfolio opportunity set in this diagram is this portion, that is this shaded portion is known as the portfolio opportunity set. That is, this portion consists of all the portfolios which we have constructed. So this is the portfolio opportunity set. The graph shows the feasible set as well as the efficient set. So here in portfolio set we have the efficient portfolios and also the inefficient portfolios. The expected return has been plotted in the y-axis and the standard deviation in the x-axis. If all the risk return possibilities, that is the investment opportunity set, are plotted on the graph area inside FABF, that is, I showed you the shaded region. This is called the feasible set or the portfolio opportunity set. And inside this, all the possible combination of selected securities are depicted inside FABF. That is, not only FABF, you can make any number of portfolios under this opportunity set. That is, you can also calculate a portfolio with return this or like this. So inside this you can create a number of portfolios. They might not be efficient, but you can create any number of portfolios inside this portfolio opportunity set. Okay. The efficient set of portfolios lies on the boundary of AECB. I'll say why they have told like that. Next sentence. All the feasible portfolios on FA have been rejected from the efficient set because there are efficient portfolios available at AC which offers higher return on same risk. That is, they have said AF is actually inefficient. AF is inefficient. Why means you can see that why AF is rejected is that you can see when you are choosing a portfolio A and the A's return is 10, suppose it is 10, and the A's risk is also 10. And when we move down the graph, when we choose any point on AF, when we choose suppose another portfolio that is here, the risk then the return. So you can see the return is below 10, maybe 5, but the risk has increased to 20. And again, if you take the portion of F, again you can see that the F risk is greater, that is 30, and again it has reduced, the return has reduced. So when anyone can get a portfolio with a return of 10 and only a risk of 10, then obviously people will choose only those portfolios that have a less risk and more return. Since this AF will be rejected, that is AF is the inefficient portfolios and AC is the efficient portfolios, because at A point we have low return and less risk. So when you look at this graph, you can see that there is two portfolios, one is E and one is D. Both have the same return, but portfolio D has greater risk and portfolio E has less risk. So which portfolio will we select? We'll select the E because it has the highest return. Suppose it is 20. Here the risk is 20. Portfolio D has a return of 20 but risk of 30. So we will obviously choose portfolio E. So D again becomes inefficient. Again, when you see the graph, there is two portfolios C and D with the same standard deviation of 30. But portfolio C gives a return of 30 and portfolio D gives only a return of 20. So C and D, C has more return than D, but the risk is same. So again, which is the dominating one? The dominating one is the C. So C becomes the efficient portfolio and D becomes the inefficient portfolio. Again, when we talk of B, B has the maximum return and the maximum risk. So they are saying that all the efficient portfolios lie on the boundary of AECB. Why they are saying like that is, suppose you take any other portfolio, suppose you take a point here. So here the risk is this much, return is this much. Obviously, the same return is got by portfolio, this portfolio, and the risk is very less for that portfolio. Then why will a person choose a portfolio here? Again, same thing. You choose a portfolio here. Here also the risk is greater and the return is less, and we have a portfolio A which is giving less risk and return at that same level. So obviously we will choose only A portfolio. So whichever point we take in this space, there is a better portfolio which has a better return and a lower standard deviation. So we say that this AECB contains all the efficient portfolios. And portfolio A has the lowest risk in the efficient portfolio set. Portfolio A has the lowest return. A has the lowest return. So this portfolio A is known as the minimum variance portfolio, and portfolio B offers the highest return at the greatest risk. So this is called as the maximum variance portfolio. Sorry, it is the maximum return portfolio. So A is known as the minimum variance portfolio and B is known as the maximum return portfolio. So The curve formed in between the minimum variance and the maximum return portfolio is called as the efficient frontier. So the curve in between the minimum variance portfolio and the maximum return portfolio is known as the efficient frontier. So this is called as the efficient frontier. Now we are going to be seeing what is Markowitz model. So all these portions which I am telling is from your text itself. So Harry Max Markowitz, Nobel Prize winning economist, devised the modern portfolio theory in 1952. This model assists investors in the selection of the optimal portfolio by analyzing various feasible portfolios. The Markowitz model is also called as mean variance model since it is based on expected return, that is the mean, and the risk or the variance of the various portfolios. This model to measure portfolio risk also identified the expected return and risk for portfolios are derived on the basis of the covariance relationship. Markowitz theory is based on the idea of risk aversion of average investors and their desire to maximize the expected return with lowest risk. So we already understood that for a portfolio we have three concepts, that is the portfolio risk, the portfolio return, and the concept known as covariance. So prior to this Markowitz model, the emphasis of people was usually picking high yielding or high return securities without considering the risk or without considering the portfolio risk. And then this Markowitz actually built the concept of diversification, that is spreading our investments in different proportions and combining the securities and reducing the risk. So Markowitz cleared the fact that the risk of the portfolio is not equal to the weighted average of single security risks. This model suggests combining securities with returns that are less than perfectly positively correlated in an effort to lower portfolio risk without sacrificing the return. By choosing securities that do not move exactly together, the Markowitz model shows investors how to reduce their risk. So in diversification we had learned about three cases, and in those cases we had seen that those securities which have a correlation coefficient or covariance less than 1 are the best ones for diversification, or by combining those securities we can diversify or we can reduce our risk. So this concept was actually introduced or taught by Markowitz. Markowitz model is thus a theoretical framework for analysis of risk and return and their interrelationship of securities for portfolio construction. He used the statistical analysis for the measurement of risk and mathematical programming for selection of assets in a portfolio in an efficient manner. His framework led to the concept of efficient portfolios. Markowitz pointed out three parameters for the construction of the portfolio opportunity set. First one, expected returns, second one, standard deviation, and third one, covariance or variance of one asset to the other asset's returns. So Markowitz actually was using statistical analysis to calculate the risk of the portfolio. So Markowitz used the technique of quadratic programming to identify the efficient portfolios. This portion actually you can note down. Using the expected return and risk of each security under consideration and the covariance estimates for each pair of securities, he calculated the risk and return for all possible portfolios. Then, for any specific value of expected portfolio return, he determined the least risk portfolio using quadratic programming. With another value of expected portfolio return, a similar procedure again gives the minimum risk portfolio. The process is repeated with different values of expected return. The resulting minimum risk portfolios constitute the set of efficient portfolios. So we know that if there are 10 securities, there will be 10 portfolio risk, 10 portfolio return, and there will be 20 or 30, that is the pair of securities that are combined and the covariance is measured. So by using these mean, variance and the covariance, he used quadratic programming, and he will determine the portfolios which give the lowest amount of risk with the maximum level of return. Not every portfolio in the opportunity set is of the interest to an investor. So we had earlier seen that portfolio opportunity set. Portfolio opportunity set means the number of portfolios we can create from the selected securities. So if we can create 10 portfolios from a selected securities, then 10 is the portfolio opportunity set. So a portfolio will dominate in the opportunity set if it has either a lower standard deviation and the same expected return, or the highest expected return and the same standard deviation. Earlier we had explained that concept. Portfolios that are dominating over the others are known as efficient portfolio, and the others are known as inefficient portfolios. So we will be seeing this in detail. Based on the Markowitz model, a rational investor will select the efficient portfolio by the following rules. First rule: if two portfolios have the same expected return, then the investor will choose the one with the lower standard deviation. So that is, if two portfolios have a return of 20 and portfolio A has a risk of 10, portfolio B has a risk of 20, then the investor will choose the portfolio with the lowest risk, that is the risk of 10. And second rule: if two portfolios have the same standard deviation, the investor will choose the one with the higher return. That is, if portfolio A has 20 return, portfolio B has 10 return, and both security standard deviation is 10, then the investor will choose the portfolio giving the greatest return of 20 at the level of risk of 10. The following table illustrates these rules by using imaginary figures. That is, I told in my example that suppose we have 10 portfolios. So we have calculated the expected return and the standard deviation of these 10 portfolios. And by the principle of dominance, we are going to see which are the efficient portfolios and which are the inefficient portfolios. So this rule, which A and B, which I told above, can also be said as the concept of principle of dominance. If you are asked what is principle of dominance, you have to write this portion. Portfolios that are dominating over others are known as efficient portfolio, and dominated by others are known as inefficient portfolio, and this is the rule for the principle of dominance. So coming to the table, when an investor compares portfolios number 2, 6 and 7, they have the same standard deviation or risk. So 2, 6 and 7. So 2 has a return of 5.01 with a standard deviation of 4.05, and 6 has a return of 7.1 with a standard deviation of 4.5 itself, and 7 has a return of 3.05 with a standard deviation of 4.05. So here we are sure that at a risk of 4.05, portfolio 6 gives the highest return. So portfolio risk has 6 has 7.1 return. So portfolio 6 will dominate over the others, and portfolio 6 will be the efficient portfolio and the others will be the inefficient portfolios. That is, we are cancelling out 2 and 7 because they are inefficient portfolios and 6 is the efficient portfolio. Okay. When an investor compares number 1, 5 and 8, even they have the expected return of 4.4%. That is, you are comparing 1, 5 and 8. 1 has 4.4 return with 3.2 standard deviation. 5 has 4.4 with 5 standard deviation, and 8 has 4.4 with 3.01 standard deviation. So here the risk return levels are same, so we are going to see which risk level is the least. So 1 has 3.2, 5 has 5.01, 8 has 3.01. So the lowest is for portfolio 8, that is 3.01. So here the portfolio 8 is dominating the others. So portfolio 8 will be the efficient portfolio. So here we saw that in 2, 6 and 7 the portfolio 6 was the one selected, 2 and 2 and 7 were cancelled. In 1, 5 and 8, 1 and 5 were cancelled and 8 was selected. So by using this principle of dominance, we are getting the portfolios which are efficient and which are inefficient. So from the graph, we had actually seen that the concave curve drawn by joining the minimum variance portfolio and the maximum return portfolio is called the efficient frontier. So this concept is the Markowitz model actually discovered that an efficient frontier can be formed from the portfolio opportunity set. So we are going to see what is this Markowitz efficient frontier. So the efficient frontier was first formulated by Markowitz. The efficient frontier is the set of optimal portfolios that offers the highest expected return for a defined level of risk or the lowest risk for a given level of expected return. So this efficient frontier, we saw that whichever portfolios you take below it, you will get more risk or less return. So Markowitz states that all the optimal portfolios will lie on the efficient frontier. This efficient frontier consists of all the efficient portfolios, and from this efficient portfolio or the optimal portfolio actually lies in this efficient frontier. The portfolios in this curve will give you the maximum return for the amount of risk you wish to accept. In other words, all efficient portfolios as well as the optimal portfolio lies on the efficient frontier. The efficient frontier takes a concave shape because the securities in the curve are not perfectly correlated. If the portfolios were perfectly positively correlated, it would have been a linear shape. So we mentioned that the diversification or risk reduction is productive only when we combine the securities which have correlation less than 1. So since we are using the securities which are not perfectly positively correlated, we are getting a concave shape. Since the efficient frontier is curved rather than linear, a key finding was that securities less than positively correlated with each other are more efficient. Therefore, it provides the benefit of diversification. So here they have given a simplified diagram of this efficient frontier. So here we can see that, before seeing, we will see the interpretations from the text itself. All portfolios that lie below the efficient frontier are not good enough because the return would be lower for the given risk. That is, they are talking about this portion. So they are talking about this portion, that is here the risk is more and the return is less, means not saying return is less, that is they are speaking about, suppose you choose a point here, the return you get is very less, but you have to suffer this much risk. Again you choose a point here, the return is this much, but the risk is here. Why it is inefficient? Because here you can get a portfolio with low risk and return. Here also you can get a portfolio with lower risk and the same return. So all the portfolios below the efficient frontier are inefficient and the investor will not choose it. And the second one, all the portfolios to the right of the efficient frontier would not be good enough, as there is higher risk for a given rate of return. So to the right of the portfolio, that is, to the right means, suppose you take a portion, this one, here you get a return but the risk is very high. You take here, you again get higher return but the risk is very high. But here you get a portfolio with a higher return at a lower level of risk. So all portions to the right and to the below are inefficient. So this full portion is inefficient. Then no portfolio can lie above the efficient frontier, as all the combinations of available securities have been tried. All the combinations are either on the efficient frontier or below. Only by introducing new securities into the portfolio set, this curve can move upwards. That is, we had seen in the previous diagram that the portfolio opportunity set was here. So all the portfolios will be here. Only if you are adding a new security, the portfolio can go here or go here. Then the optimal portfolio always lies on the efficient frontier. This is the most important thing, that is, the optimal portfolio is chosen from the efficient frontier, and the efficient frontier takes a concave shape because the securities in the curve are not perfectly correlated. So how to choose a optimal portfolio from the efficient frontier? This will depend on the investor's risk tolerance. That is, here they have given here low risk, low return. So an investor who is risk averse will choose a portfolio from the lower segment. An investor who is a medium tolerating person will choose a portfolio from this space, and a high risk taker would choose a portfolio from this place. So all efficient portfolios and the optimal portfolio also lies in this frontier, and the investor can choose the optimal portfolio from this efficient portfolio based on his risk return characteristics. So coming to the limitations of the Markowitz model. First one, false assumptions. That is, we saw the assumptions that investors are rational, avoid risk when possible, etc., etc. So all these are not actually relevant or true for the market. Then second one, validity of historical data. The theory does mathematical calculations on expected values based on past performance. However, the experienced investors could not consider past performance to be a guarantee of future performance. And third one is the complexity of computation. That is, we saw that there were three, that is mean, then variance and covariance. So if there are 10 securities, the covariance will be again higher. If there are 100 securities, the pair will be higher, the covariance estimates will be higher. If there are n number of securities, the investor needs to calculate n number of expected return, n number of estimated variance, and n into n minus 1 by 2 estimated covariance. So for 100 securities, there will be 100 return, 100 variance, and 4950 covariance. So using quadratic programming, he will select each value. So the calculations will be complex. So that's all about the Markowitz model. So Markowitz model is a model for choosing the best portfolio. Markowitz mentioned that from the portfolio opportunity set, there is portfolios that are dominating over the others, and these dominating portfolios are known as the efficient portfolios. And from this efficient portfolios, we can draw an efficient frontier of portfolios, and this efficient frontier consists of all the efficient portfolios, and the optimal portfolio is selected, or optimal portfolio lies on this efficient frontier.